Yes, let's continue. Developing services. First of all, you have to think about your architectural design. Can everybody listen here now? We have to think about the quality of service, and we'll look at some attributes that are related to quality of service. And we'll look into some typical challenges like transport, messaging, security, etc. As we remember from the service-oriented computing lecture, typically we want some features there when we develop this kind of systems. Services fulfill business roles and encapsulates functionality related to the role. We want some capabilities. The functionality of the service corresponds to the capabilities of the role. And we want arm's length interaction. Avoid unnecessary coupling, dependencies, etc. This is why we build service-oriented systems. We want reconfigurability. Services should be able to be relocated and reconfigured. Caution, services are subject to threat and must deal with other parties cautiously. There are specifications for handling requests between services, for example, OAuth. We want narrow interfaces, avoid exposure of implementation-related detail. The interface is what matters. We want to only expose the interface. Okay, there are a lot of engineering aspects of service-oriented computing. Ontology engineering. That topic will be helped by Rune in the next lecture. Semantics and ontology engineering and so on. Typically, we set up a process model in our service-oriented systems. How should the components interact? How should the information flow in this system? We set up a plan for composing services. Maybe we utilize 10 different services. How should they interact and what kind of information do they send and so on? Typically, we measure service quality with some kind of attributes that is measurable. And we define exception classification and handling within the service. Okay, what is ontology engineering then? Ontologies are descriptions of concepts of classes and their relation. So we can define, with ontologies, we can define classes of objects. So this is metadata about a collection, for example, of objects, and defining how they are interrelated. For example, a mammal can be related to, for example, human as a species. We can build ontologies and build these relations and define them in these kind of ontologies. Ontology construction is an engineering art which demands practice, like conceptual thinking. And you build ontologies or you define them based on domain knowledge. Then you need experts, like specialists in the knowledge domain, for example. Or you, as an IT expert, elicitate this domain knowledge and you define the ontology based on what the specialists know. Okay, another aspect in service-oriented computing is creating a process model. You typically analyze the information flow and system workflow to construct a model of system process tasks. System modeling, have you been doing that a lot? UML model, some kind of modeling notation. You can think of it the same way, but in this context, you are building process models on services that needs to interact more than components within the system that need to interact. 4 general strategies in creating processes, and this goes for service-oriented modeling and ordinary software modeling. You can either search forward from a start state to an end state. Okay, this is the object or the information that I start with. This information should go through a lot of transformations and end up in this state. For example, an inquiry from a client should go through a lot of processes until it maybe turns or transforms into an order of some kind. You see? Typically you define process models for that. And you use modeling notations that you know, like notations in UML or notations like workflow diagrams or Petri nets or whatever. Another way to do this is searching backward from a goal to a start. Okay, we have this order. What is the workflow to get to this state? So we start with the order and we backtrack the states or the transformations back to the original state. These are 2 ways of doing process modeling. And the last one is task decomposition. Okay, we have this major workflow where we define like support. That's a major workflow. Okay, how can we decompose support? We can decompose it to user registering an issue. Okay, there we have some information, an issue, and maybe there should go some email notifications out to maybe a developer or maybe a project leader or something like that. We decompose it into these workflow transformations, and then we get a process model of our system. This is the most popular approach, typically divide and conquer, recursive decomposition to smaller manageable pieces. And the last one, successfully defining the operations needed to transform an initial state to a final state. Process modeling in 5 minutes. Okay, composing services. Based on this process model that we have built or we have modeled, we start composing services. Okay, are there services that we can use that is already developed? Yes, let's set that up. Or we use them as they are, as a software as a service, for example. Service composition, putting services together to achieve some desired functionality. Okay, we identify the services that we need based on our process model. It's quite not entirely different from what we do in service or software modeling. When we build components, we plug in the components based on what we want to achieve with the system. So we have identified our services that we need to go from, for example, inquiry to order, or maybe a bank transaction in a mini bank to money actually on a different account. These are different processes that we can compose with services. What is the goals for doing this. You want more powerful utilization of services than that of straightforward client-server interactions. And we want composing complex applications combining data and functionality to perform several services. Yeah. So that this means that if we are working with enterprise applications or enterprise services here, large systems, we typically have the opportunity to reuse a lot of components, a lot of services. So we plug in the services that we want. Okay, we move on to identifying the existing corporate services. Maybe we have a system already up and going. What kind of services are we using? We construct missing essential services either by scratch or by outsourcing the development or by locating existing services providing sufficient functionality. And then we select, plan and specify the desired combination of services. And we test and execute the composition of services and monitor for errors. So these are quite basic steps in composing large systems based on services. Have you heard about microservices? Yeah? It's quite popular now to build your system based on tiny, small services doing small transformation of data. When you're composing microservices, you do it in the same fashion as you do with REST services or web services. Okay, it requires capturing patterns of semantic constraints on how services participate. This is typically in a web service context. And you want to maintain global coherence without explicit global control. What does that mean? You want the services to interact together without having a master service, more or less, or a master software of some kind monitoring these other services. You want them to interact without this monitoring service. So you want to leave global control out of it. Okay, how can we model processes? Some notations are mentioned here, like workflow modeling, causal modeling, process modeling, sub-goal graphs. Some of these are UML notations as well. Some you may have used or not used. Okay, engineering composed services is a process of discovering and composing services to satisfy a specification. We already talked about that. Okay, now we have composed a set of services talking together. But we also want to have some kind of transaction control in these systems. For example, you don't want this withdrawal of money in your mini bank resulting in not decrementing your money in your actual account. So you want to ensure that that transaction goes well, the whole transaction is done. And how do we do that? Composing services involves handling and choreographing chains of transactions. These are workflows. This is information that goes through transformations. We have some standards that we can use for this if we build web services with WSDL and so on. There is a web service choreography description language, WSCDL, Web Service Choreography Interface, WSCI. Okay, what is a transaction then? Money transaction, that's a typical example of a transaction. It involves a lot of steps and a lot of parties that are involved. Typically, if you swipe your Visa card, there are a lot of steps involved in moving money and decrementing your account and so on there. A transaction is any activity that creates, updates, or deletes data in a database. Or in several different databases at the same time. Typically, we talk about transactions in a database context. In a database context, you have a DBMS, which is responsible for ensuring consistency. Okay, if you have one transaction involves 3 different steps for a database. The database needs to ensure that all these steps are valid and okay before the entire transaction is done. This is the typical way of handling it for databases. So, whenever you have success in all your steps, you have a successful transaction, and then you can commit your data. You can actually save it to your database. But if any of the steps fail, then the entire transaction should fail as well. You see? If it doesn't, you may have an invalid state of your data in your database. So successful transactions are committed, and unsuccessful are aborted or rolled back, typically you would say, in a database context. Yeah. And in the database context, you also talk about ACID properties. Atomicity. In a transaction, all or none of the operations are performed. If all succeed, okay, we have a transaction and the transaction is okay. If 1 of 10 steps or operations in that transaction fails, the entire transaction fails. You want consistency. Concurrent operations generate consistent results. And you want isolation. Partial results are hidden for other parties. So one step in the transaction or one operation, the results from that operation should be hidden from the other operations. An operation should only have input and output, more or less. You want durability. All committed results are permanent. So successful transactions that results in committed data means that the data is permanent. It's permanently stored. This is in databases. We are going to look at ACID properties in service-oriented systems. Because we are talking about distributed transactions. In database systems, you have quite an environment that you have control over. DBMSs have a lot of control over this transaction and the operations in the transactions. But in distributed systems, where you have services, maybe 5 services that are involved in one transaction, this is a lot harder. Transactions running in a single database is called flat transactions. On distributed systems, we need to create nested transactions. Distributed transactions are often controlled by a transaction processing monitor, a TP monitor. Okay, let's look at ACID in distributed transactions. atomicity. You want all sub-transactions being performed and being valid. You want consistency in that nested transactions is correct if sub-transactions are. And isolation, different nested transactions are unaware of each other. So you feed the operation with some information, and it outputs some information to the next operation, more or less. But it doesn't know anything about the other operations in the transaction. And you want durability. Nested transactions are durable. And you see that in web services versus REST architectures, there are a lot of differences in this actual topic related to transactions. Because in web services, when you pass SOAP messages between different parties in a transaction, you can also use standards for ensuring that this is the same transaction, maybe using tokens or some kind of identifier of the transaction. You have a lot of more features than you have in REST APIs. So you can have conversations with intermediaries in a web service, maybe using SOAP. It is entirely possible with REST APIs as well, but you don't have a standard for it. Maybe you can use tokens of some kind, OAuth tokens, JSON Web Tokens, or something like that to identify your conversation between the services. But this is not a standard. That's just a way of doing it, maybe. And then you have to configure all your services based on it. If all your services support a standard, like the ones we have with the web service standards, it is easier to set them up. So for large systems with transactions like this, with multiple parties and multiple services involved, it is actually more convenient to use a web service approach with the web service specifications rather than a REST approach. And here you can see, in these examples, you can see the power of large frameworks that has this incorporated and uses these specifications and standards out of the box. Okay, how do we measure quality in service-oriented architectures? Do you remember I had a talk on quality measurement in software development in the project course that we had last semester. So also you were there. I'm going to talk about quality measures now in a SOA context. It's not entirely different. You will see some resemblances from what I talked about then. The main thing is, when you have a system or a service-based system or a typical software or something like that, you want to measure quality. And how do you measure quality? That's hard, because you have to have some kind of measurable quantities. So you have to be able to quantify something, quantify an attribute of a system, so that you can measure it. It's difficult to measure something without having a number. So in a scale from 0 to 10, is this 2 or is it 8? You have to quantify the quality of your system or your service-oriented system. Okay, what kind of measures do we have? Typically you have metrics beneath these type of measures. So, for example, availability. This is a measure of whether or not the service is present and ready for use. Can you think of a metric for one metric for measuring availability? There are different kind of metrics you can use, but can you think of one example of a metric that you can use for availability? Is it uptime? Uptime, yeah. That's a typical example of a metric. So you can have a service with 99% uptime. Is that good or bad? It's not that good. You should maybe have 99.9% uptime. But that's not relevant here. The main thing is that we have quantified the attribute. You see? It's a number. And we can relate to numbers when we measure quality, rather than just looking at it and nice service, that works good. We want numbers. So availability, measure whether or not the service is present and ready for use. Accessibility, measuring the likelihood that the service can satisfy a request at a given point in time. A service may be available but inaccessible due to network congestion, etc. So it's not only the service itself that determines if a measure is good or bad. It also depends on the network and the infrastructure that the service is on. You want integrity. It's a measure of how well a service maintains correctness of interactions and transactions. You want to measure performance. Throughput is the number of services requests, and latency is the round-trip time. And those are two typical attributes, or metrics that you can use. Latency, round-trip time. You want reliability. It measures how often a service meets or exceeds its advertised capabilities. Compliance measures how well a service complies with the service level agreements, rules, laws, standards, etc. You want security, and this measures how well a service provides confidentiality, etc. And honesty measures how delivered qualities correspond to advertised qualities, and price, this measures the cost of using a service. Based on different metrics in these kind of measurements, you can maybe infer a value of how good the system or the service is. Quality of service. Okay, how do we do exception handling in service-oriented systems? Service-oriented computing systems have diverse, distributed, and autonomous components potentially exception-prone. And one component doesn't know whether or not another component is working like it should. Because, as we want in service-oriented systems, these are autonomous components. So what are exceptions? Things that go wrong, errors and faults, deviations from normal patterns of activity. You have different classifications of exceptions. Programming exceptions, I suppose you know those. You have met them in your development projects. Maybe solve them with try-catch blocks and so on. You also have system exceptions, networking and operating system exceptions. And you have management exceptions, resource management problems such as transactional obstacles or errors. So errors that reside whenever you're doing a transaction. Semantic exceptions. Preconditions are not met or postcondition is obtained that violates some integrity constraint. Pragmatic exceptions. Violation of commitments, practical exceptions. These are typically related to real-world processes. Yes. Any questions to transactions and exception handling in service-oriented systems? No? We should have done this workshop last time. Try to build a basic REST API with resource endpoints that support get, post, put, and delete. Use an entity of your choice from the example in these slides. Cars, books, products, etc. Have any of you worked with this workshop? Yeah. Try to set it up. It's quite convenient to learn about these REST APIs. So I will encourage you to do this workshop and the workshop that's originally for this lecture. But yeah. Yes, that was REST APIs. Should we move on to web applications? 10 minutes. There won't be much time for a workshop today. 10 minutes more, and then we'll take a 10-minute break, and we'll take the last session after that. Okay? You're still awake? Are you? Yeah. Web applications. Okay. Topics: storage in your web application, caching in web applications, threading and interaction in web applications, communication, web components, and multimedia and graphics. I should actually have two lectures for this topic, but we'll try to get through it. HTML5 web applications. In HTML5, there were defined a lot of new APIs that you can utilize and use in your web apps. And we talk more about web applications now than we did before, because now it's possible to build web pages that are not performing, but that are functionality-wise quite like ordinary applications. That was difficult before. So what kind of APIs do we have? Okay, first of all, let's go offline. What are the challenges when we go offline with a web page?
It's basically useless.
Yeah, it is. Because you can't retrieve the information that you want. And if you have some kind of XML HTTP request object, the functionality, HX, you can't retrieve information asynchronously either. So what we should look at now is that with new standards, it's not that useless. Do you want some coding examples? Yeah? Events to listen to. Window.on online and window.on offline. you can determine whether or not, let's open a web app that I've got here. And let's do some coding. Can you see this? Ah, we can see this. Maybe we should provide the event as well. Yes. Now we should have some alerts whenever we go online and offline with our app. Okay? And that means that if I turn off my Wi-Fi here now, it says offline. And I turn it on, it should say online. Yeah. So we can determine whether or not a web app has internet connection. Okay. so we're a little bit further than we were for a few minutes ago.
How does it check it? Does it check that there is no internet connection, or it's just there is like network device?
Yeah, the actual there's some deviations there based on what kind of platform you're on and what kind of browser you're on. Chrome is typically, I think it's listening to whether or not the network protocol is connected to some outside. It has internet access outside the local network. How it does that, I'm not sure. But it gives us a little more opportunity than we had without it. Let's go on to what we can do more. We can also enable local storage or store information in our web browser. We can do that in several different ways. One specification is local storage. These are key value pairs set by JavaScript code with set item. So this is an interface that is defined by and a specification by V3C in the HTML5 specification. The interface has the method set item and get item. Quite easy, quite basic. Value that is stored is type text. So you have to do some kind of type conversion if you want to store values of some kind. No, numbers or floats or something like that. You also have JSON.stringify and JSON.parse. So you can store objects by serializing them to JSON, store them in local storage, retrieve them, and deserialize them. It's quite similar to cookies, but these are not sent to the server. Cookies are. There are two types of storage, session storage and local storage. Okay, the local storage API. Data is available to all Windows tabs from same source. So if you have a domain /index.html, for example, you can retrieve the local storage information from different tabs and different windows as long as it's on the same domain. It's useful for application settings and data that has not yet been sent to server or stored in database. Session storage. This is data stored with a window object. And that means that the data is discarded when window is closed. It's useful for window-specific state data. Okay, let's... Sorry. This is one way of doing it. Local storage.foo equals bar. Then you set the variable foo in local storage to bar. Or you can do local storage.setItem foo with value bar. That's the same thing. Those two are the same thing. So let's try that. Now I set local storage.myValue equals foobar. We can use the Chrome inspector to look at the local storage on Resources tab. Can you see this? You have a local storage, and here you see that the value set for localhost is myValue, foo, and debug. So I've used this before. I can remove them if I want. But my value was the value that I set now. So this is how you use local storage. I can also store, let's try with the json.stringify and pass a JavaScript object. Let's see what it does then. Yes, you see that it stores the string. JSON.stringify serializes the object. But this then means that I can instantiate this by doing something like this. Console.log json.parse local storage.myValue.
Do console.dir instead?
Console.dir.
dir.
Here I've got an actual JavaScript object. Yeah. So it's possible to store objects as well, but you have to serialize them and deserialize them. So it's not optimal for doing that. We'll look at other solutions as well as we go on. We also had this specification called WebSQL. Have you heard about that? It doesn't matter actually, because it was deprecated. But I had to talk a little bit about it in earlier years in this course, until it was deprecated. So we're moving on. IndexedDB. That's the way to go if you want a database in your client. This is an object store. Do you know other object stores? Yeah, MongoDB, CouchDB. Others? There are a lot of different object stores. So this, I won't say that the APIs are different, so I can't say that it's the same. But the principles are the same. We're storing JavaScript objects. In MongoDB, you use something called bson, which is a binary version of a JSON object. in IndexedDB, it's more or less the same principle here. Okay, it was proposed by Mozilla, became a v3c recommendation 8th of January 2015, so we can use it now as a recommendation, recommended specification. And it gives easy access to persistent objects using JavaScript. No advanced query language. It uses indexes for content-based access. Typical sequence of operations in an IDB operation. Open a database and start a transaction. Create an object store. Make a request to do some database operation like adding, deleting, or retrieving data. Wait for the operation to complete by listening to the right kind of DOM event. Do something with the result. So typically if you want to store something, you use the API of IndexedDB, store it, and then you start listening, or before that you start listening to an event and provide an event handler. And with this event handler you should handle any operations that you want to do after the object is stored. Objects in IndexedDB, an object store may hold any type of objects. All objects are identified by key value. Keys should be immutable, no mutations. Key paths in IndexedDB, when a JavaScript object property holds key value, and you also have key generators in IndexedDB, like MySQL, you have auto increments, or Postgres, you have auto increments, and typically in any database actually creates keys automatically and increments them automatically. Currently, IndexedDBs are asynchronous. On-error and on-success callbacks are called when requested operation is completed. So you have to listen to these events if you want to do something after you save an object, for example. Transactions are short-lived. Entering browser event loop will implicitly end the transaction. So this is an example of how you can use IndexedDB. This is an object, an array of objects. We use window.idb transaction.readWrite and instantiate the transaction with db.transaction and the object store name, if we have a name for the object store. So of course we can have different object stores with different names and namespace them. And then we can retrieve the object store that we want to use. Transaction.objectStore with the object store name. And for or iterate through these messages, we use store.add to save the message. In this example, we are not listening to on-error or on-success callbacks because we don't want to do anything after the transaction has either failed or been successful. So you should have had an on-error callback at least. So, two alternative functions for adding or putting. Add for adding new objects, or put for modifying objects or adding new if the objects do not exist already. So actually you can use put for anything. Getting data, you have the get operation or method. And for iterating over a set of objects, you can use open cursor. You can also do complex queries. Indexes can be used to sort the result set. Cursor ranges may be defined for iterating over a subset of a result set. And filter functions may be called when iterating the cursor over selecting given objects. Okay, delete data. Delete and provide a key. Or clear to clear the entire object store. And to delete the actual object store, you use delete object store and provide a name. Yes. Here we see an example of creating an object store. We jump into this line, db.setVersion, so set a version for the object store. And we provide an unsuccess callback. Whenever the version is set, this is triggered. And then we create the object store with an object store name. And we create the indexes that we want for this actual object store. Okay, the file API. This is browser access to the file system.
Could go wrong here. No.
What?
There's nothing that could go wrong here. No.
No. No. And it's maybe that's why it's not a recommended specification yet. I'm not sure what the status of the specification is now.
They have killed it.
They have killed it.
The browser is supposed to be a sandbox.
But it's sandboxed. It's not.
If you access the file system, it's not sandboxed.
No, it's not like real file system with the normal sandbox file system. So you can create files.
So you can access one folder.
Yeah. Okay, like that.
Yeah, you're restricted, of course.
So it's a normal storage thing.
Yeah.
So how is it different to key value storage?
Well, just the
A fail API.
Yeah, different.
In the same difference as you have in your catalog structure in your file system as you have in a DBMS. So,
10 ways to do the same thing.
But it's always the case. You can always have database for file in your ordinary applications as well.
Yeah, but usually that's the application can access the rest of the file system and can interact with the rest of the file system. This adds nothing.
we wouldn't say that, because you have a lot of, if you want access to files or save files that you want to utilize in other applications, for example, in different kind of formats, you won't store them in an object store. Those you store as files in your file system.
Object store is still a file.
Sorry?
Object store is still a file somewhere.
Yeah, it is. But a PDF, an actual PDF that is already encoded, files that are encoded with some kind of media encoding, then you want to store them as files. That is what the typical practice of ordinary systems as well. Store them as files, not as blobs in your DBMS. That would be congestion in your DBMS, and you wouldn't have performance as you have with retrieving the files from the file system. So of course you have to think of these things and consider them before you implement it. But there are pros and cons with everything. But let's look at the file API. Reading files and data chunks within files. The file API, you can manipulate file objects client-side. File reader API, you are able to read a file or blob object. And the file system and file writer API, you're able to read and write files to sandboxed file system. You can look at the file system article from what site is this? HTML5rocks.com. If you want to look into it, there are applications utilizing this specification, but if it's deprecated, then you won't have access to it in your browser. But typically in HTML5 based systems like Firefox OS, I suppose, I can't say it for sure, but I suppose they are utilizing some kind of dial API with merely the same interfaces. But what we want to have in our web applications is caching. When the application cache proved insufficient, service workers was proposed. So this is a proposed standard, service workers. We'll look into, in caching, and we're talking about caching here. We'll look into application cache, and we'll look into service workers. So what is the motivation for caching? Offline apps needs access to essential resources. Okay, what is the offline application cache? The first time you visit a web page and you have a configuration file for your application cache, or the browser detects a configuration file for your application cache. It downloads all the files that it needs, and it puts those that are supposed to be in the application cache into the cache, and not with the others. So in subsequent visits, files in the offline application cache is used unless the manifest file has changed. And this is the configuration file, the manifest file. This is how you configure what resources should be cached and what should not be cached. We'll come back to the manifest file. So it's all about the manifest file. So in this way, we can, for example, cache our CSS. We can cache the JavaScript of the application. We can cache images that we utilize in our application, and actually have a web app up and running without having internet access, because we have our JavaScript functional logic, we have our style sets in our CSSs, and we have an HTML, and so on and so on. So this means that we are not entirely dependent on an internet connection for web pages now. The offline application cache is stored in the app directory. It must include a file header, cache manifest, and it should provide an HTTP header content type text / cache manifest. And it must list all files required by the app. So this is an example of an app or a manifest file, defining what to cache and what not to cache. Here we should cache index.html, images / icon.jpg, scripts / myscripts.js, and style / mystyle.css. So these are stored and then used if you're offline and using this web page. And we can also provide fallback files for anything in the images file, the images directory, except icon.jpg, because that's cached. We should provide a fallback image offline.jpg. Oh. So fallbacks, pairs of network and cached files. Cached file used if network file fails to download. You have a network whitelist, files that should be loaded from the network and not from the cache. And in JavaScript you have an application cache API, application cache.swap cache, to load new cache into memory. and application cache.update ready. This is an event that is triggered if changes are detected in cache manifest. Remember that the browser won't update its cache files before the cache or the manifest file is changed. So if you want to trigger a new download of files, you have to change your manifest file, which is actually quite inconvenient. Another approach to caching and handling background work in web applications is service workers. Service workers provide periodic background syncs, push notifications, caching tools. Yeah. I think it's still a V3C working draft. It was last year. Let's look at it. Yes. You want to look further into it than I'm talking about it now, you can look at the article that I have provided. Okay, the thing with a service worker is that this is a background thread that is working independently from your web app. But it has interfaces to your web app, and the web app has interfaces to your service worker. So the service worker can provide information to your web app, and the web app can fetch information from your service worker. So you can look at it as a thread that is working behind your web application.
Question, is this the same as web workers?
No. We'll come to web workers. So how do we register and install a service worker? This is one of those APIs and the specifications that are dependent on having a web app working on HTTPS. So you have to serve your service worker JavaScript file over HTTPS. But how do you register a service worker script? In this example, we have navigator.serviceworker.register, and we provide the URL or the address, the relative address to the service worker script. So this is a service worker is actually a JavaScript, and you provide one callback. One for successful registration, and you also could call .catch on that fallback to catch any errors that occurred when registering the service worker. In a service worker, you can listen to an install event so that you can do some init functionality whenever the service worker is installed. Maybe start fetching resources, or maybe doing other background work that you need to do in your app. Okay, what does this have with caching to do? With a service worker, we also have the possibility to utilize another API, a cache API. This is another way of doing caching in web applications than with the manifest file. You can do it entirely in your application. So here you can perform install steps. Event.wait until caches.open. Okay, now I have a cache. Then I can do cache.add_all, and I can provide a set of URLs that I want the service worker to cache. What does that mean? It does mean that, okay, these URLs should be cached. So whenever there are requests for these URLs, you should get them from your cache instead of getting them from the server. Okay, how can we do this then? We can listen to a fetch event. A fetch event is triggered whenever resources are trying to be fetched by the web application. Okay, we listen to a fetch event. And in the event object, we can say that we respond with, and we can try to catch the event.request, that's the request URL, try to match it with what we have in our cache already. If we have it in your cache, it's a cache hit, and then we just return whatever was in the cache. If it's a cache miss, we fetch the event request, and we should have cached it as well. This is a more dynamical approach to caching than the manifest file, which is quite static. In this way, you can also choose, depending on choose what to cache and not to cache, depending on several different parameters, rather than just having a list of valid URLs to cache. Okay, what does this mean? We can have actual applications working and caching the resources that we need. This is a demo, train to thrill. This is a demo to show how service workers are used in, for example, the Chrome browser that supports service workers. Let's see what kind of browsers we can use it in. We can use it in Firefox, Chrome, Android browser actually, Chrome for Android, until now. Yes, let's look at the example. Okay, this looks like an ordinary web application. It fetches Instagram images, I think, on train images from Instagram. Nothing new to see here. We can reload the images. But the main thing is when we turn off our Wi-Fi, we still have the same information available. And these are images that were fetched from Instagram. So this you couldn't have configured this in your manifest file because it's a different domain and so on. So these are images from Instagram. And what it does here, it uses this cache in the service worker to save those images and those texts to the cache of the service worker. So it saves the requests, and it still has the requests available if I reload this page now. So we're still on GitHub, train to thrill, and it still works as intended. And this application is built offline first. So you think of it as a normal application. So you check whether or not you have the resources available. If you don't have the resources available, you fetch them from the server. Not the other way around, which is typical. Fetching the resource from the server. Okay, no, I can't get it from the server. Then I check my cache. So it's cache first.
summarize the entire point of service worker just to handle offline caching?
Yeah, not only, but the cache API that you have in service workers are for offline caching. You can also use service workers for background jobs, like let's say that you set up. I'll come to that with server sent events. Let's say that you have a server sending you notification, pushing your information. Then you can have the service worker listening to that and push those notifications onto the web app. So you can have a lot of background work being done in the service worker. Why is it called, let's see. Yes, why is it called service workers? There was a question of web workers here. I will show you what web workers are. It's a different specification, but they are related. So we'll come back to what workers are in JavaScript. Okay, I forgot the break, but should we just continue now for 15-20 more minutes and then say it's okay for today? Or do you want that break? Oh, just continue. Yeah. Threading and interaction in the web apps. Threading, that has been a difficult thing in JavaScript for ages. It hasn't been possible at all. Interaction has been possible, but we'll see other interaction patterns here. You have the messaging API. This is for interaction. Messaging between frames. So you can have one frame for one GUI, for example, sending messages back and forth to another frame. So you can have, before it was possible before as well with JavaScript, but only on the same domain. But with this messaging API, you get the conform API for sending messages back and forth from different domains as well. So you can have one window showing you a web page from one domain, sending messages to another window from another domain. So it's for message data passing. Current implementations only handle string data, and objects need to be serialized with JSON.serialize, for example. Okay, messaging API example, post message iframe across domains. So I can do document.get element by ID, my iframe. This is an iframe in your web app. And then I can use this frame with iframe.content_window.postMessage. So that's the API, post message, to post messages to other frames. But this iframe has to be set up with what was it? Was it receive message or was it? It was an event listener. Where you listen to message events. So this iframe has to have this event listener implemented and have a handler for that, for receiving the messages. So you can't just send messages and hope that they are used by any iframe. It has to be set up for that. So you use window.add event listener message. Then you know that there is a message coming, and you use you define some kind of handler function for handling this message. So that's for messaging, interaction between frames. Now we come to web workers. Web workers are threading in web apps. These are parallel processing in or threading is parallel processing in programmed applications. Multi-threading, I suppose you have heard about that. So web workers enables this in web apps as well in JavaScript. So you can have several processes running simultaneously and sharing resources such as memory. Suppose you all have experienced these web apps hogging all your resources in your web browser because of some kind of procedure that uses a lot of resources. With multi-threading and web workers, you can put these processes aside and let them work for itself. And web workers interact with each other via messaging, and then they use the same API as the messaging API. Post message, and you have to listen to the message event. That means that you can have your web app posting a message to a web worker. If that web worker listens to the message event, it will handle that message, and the other way around. Yeah, you can have a web worker doing post message to your web application. Then your web application has to be set up with handling the message event. So here you see an example of that. You have main.js. If worker in window, this is just a check whether or not web workers are supported in this web browser. Worker, new worker, worker.js, so it's a reference to a JavaScript. And you set up your event listener in worker.js. It listens to message event and do cool rad stuff based on message received. Okay, but you can't do anything in web workers. You don't have the entire spectrum of functionality that you have in your application JavaScript. These are the allowed functionalities that you have. You can access the DOM window object, DOM window object, document object are disallowed, but you can set event listeners. You can do AJAX requests. You can set timers with set timeout and set interval. You can use core JavaScript functions. Eval is none. You can use WebSockets. Navigator and location objects are available. You can use the event source API. WebSQL, IndexedDB are available. Web workers, so you can use new threads in your web worker. And you can import scripts. There is also a specification called shared workers. It's the same as web workers. It's threading. But the thing with shared workers is that multiple documents can access the same instance of a worker. So let's say that you set up a worker and you have two web browsers up and running. Both of these browsers can use the same thread, same web worker. E.g. frames, sharing a worker which serves these frames simultaneously. It may be used for syncing data between frames, and it implements an onConnect method in addition to onMessage of the plain worker.
My understanding is, did you just say that you can have Firefox talk to Chrome or two tabs in Firefox talk to each other?
No, these are frames, tabs in Chrome talking to each other. Okay, let's move on to app communication. From pull to push and full deep duplex. Because in its origin, HTML, JavaScript, and web apps were pull-based. I suppose you know what that means, but it means that you can only request resources. resources can't be pushed to you. Can't be pushed to your application without you doing a request. But we're going from pull to push and full duplex. And how do we do that? We have new features in XML HTTP request. We can track progress. Many types of events are triggered, e.g. data chunk sent. So we can use these events and listen to them and have handlers on them. File uploading, file or blob as parameter to send function. And you can do cross-domain AJAX requests for browsers supporting the cross-origin resource sharing specification, CORS. It sounds quite complex, but it's only an HTTP header that says that, okay, we receive CORS, or you are allowed to do cross-origin resource sharing on our server. First of all, push. We have server-sent events. Have you heard about server-sent events? Yeah. It's push messaging to the server over HTTP. Sorry, that's push messaging to the client over HTTP, not the server. It's based on an event source API. The event source object is an object that you can instantiate in JavaScript. Okay? And the event source object tries to maintain a persistent connection with the server, as long as it can do that. And if it loses the connection, it reestablishes this connection. So as long as we have this connection up and going, this means that the server can send directly to the web application. So you can push things without the web application requesting it. And then we need some event handlers. We need on-open whenever we're instantiating and opening an event source stream. And on-message whenever new data comes through this open socket and open connection. And we need on error whether or not errors occur. And the message meme type that we use from the server to the client is text/event stream. Okay, how do we do this? This is a stream server-sent events example in PHP. We set the headers that we need, and we construct some data. Typically, we denote one message line with ID : and we identify this message with an ID. And then we send the message with the server time to the client, pushes it directly. The client, you instantiate a new event source with the address to the endpoint, stream.php. And then you set an on-message handler. This only console logs the data that is coming from the server, but you can do anything. And you can also set on-open and on-error handlers as well.
Question regarding.
Yeah.
PHP only execute code when it got an incoming request. So does this mean that the client is sending constant requests to the server, and the server chooses to answer if it has a new message to post?
No, it keeps the connection alive, but how it uses it in PHP, I'm not sure. utilizing within PHP. But it doesn't do subsequent requests.
It's only one like request that keeps connection, like one polling request, and then you just whenever you have something to send to client, you just send on this socket data, and whenever how it's implemented in PHP, I don't know.
It's easier to explain it in Node, for example, because there you have a persistent operation going on whenever you set up this kind of event source object. So whenever, and this typically listens to other events on the Node.js server. So if something happens in another process, it catches that event and it sends some information back to the client. And supposedly it does that in Java as well. Some of you have to be aware of, with server-sent events you send text messages back and forth. So you have to serialize your objects if you want to send objects. Okay, WebSockets then. WebSockets. Once server-sent events is done over the HTTP protocol. WebSockets are not. This is TCP sockets that is set up. So WebSockets provides a full duplex real-time communication stream from a server to a web client. With the server-sent events, it was only the server that could send information to the client, not the other way around. The client initiates the server-sent events dialogue or the communication, but it's only the server that can send to the client. You see? But with WebSockets, both the client and the server can initiate sending data without doing any requests. This is communication over a TCP socket. It's not over HTTP. So typically, the web browser, if you want to connect a WebSocket, the web browser sends an upgrade request and says that we want to upgrade to communicate over WebSockets. And then it negotiates with the server, and okay, it's set up, and the communication then goes upon TCP. The server is able to push messages directly to the client. And it solves latency of real-time applications. Simulating push over HTTP usually means AJAX polling or long polling, and this is resource demanding. And these methods typically results in high latency. The WebSocket is always open and enable client to send the server streaming data asynchronously over the same connection. This opens for a wide range of real-time applications with real-time communication able to stream data between each other. And it's not restricted to text data, you can send any data, binary data as well. That means that you actually can stream, for example, video information. You have other protocols that are more suitable for that, but you can do that over WebSockets as well. And you can also stream any kind of data actually. The WebSockets API, it's application communication based on messaging passing as in web workers. So it's using the messaging API and it's using the events as in web workers. So you have event handlers on message, on close, on open, and on error. And it has the methods send. It's a WebSockets example here. You can look into it yourself. I think I'll wrap it up for this time now. Let's see if we have much left. Web components, that we can do that next time, so that's not a problem. Multimedia and graphics, yes, that's also suitable for next time. Okay, let's remember that. I stopped at WebSockets, and then we'll catch up from there the next time we meet in 2 weeks. Yes, that's it for now. Any questions? No?